Okay, this is the second video, I hope, that you're watching. So we're just continuing where we left off. So 128. Whenever you see an even number, think of it as something you can cut in half very easily. And if you know what half of 128 is, I think you just found something good. 2 times 64 is 128. Now, if you didn't know that, you know, the calculator can get you other factors and stuff, but this is something you're going to have to play with. So again, square root of 64 comes out. The square root of 64 is 8. The answer is 8 radical 2. Check it. Turn it on. Take the square root of 128. A little more than 11, because this is more than 121. 8 radical 2 equals, again, the same answer. We did those. All this guy just means is whatever that answer is, put a negative sign in front of it. So what are the factors of 8? Well, that's easy, right? Factors of 8 are 4 times 2. Which one of these is a perfect square? This guy. And I just slapped the negative sign in front of it, so the answer is negative 2 radical 2. Okay, last two on this page. 45. 45, wasn't that? So all this means is take whatever this is and multiply by this number. Multiply by negative 5, whatever this is. So negative 5 times, let's see, the square root of 45 is 9 times 5. This guy's a perfect square, so bring out the square root of 9, which is 3, so just multiply that, leave that. Negative 15 radical 5. Negative 15 radical 5. Last one is a decimal. Think of this as money. If you ever have problems with decimals, think of it as money, and that's 12 cents. So I could say, hey, one person could get me 12 cents. 2 people could get me 6 cents. 3 people could get me 4 cents. I underlined that for a reason. I wonder if you know why. 4 people could get me 3 cents. And I underlined that. Well, the reason is both of these are perfect squares. Well, which of these pairs has a greater perfect square? 4 is clearly greater than 0.04. So use these two right here. 4 times 0.3. And again, the reason you use this is he's a perfect square. He comes out, becomes a 2. 2 radical 3/10. Try it. Take the square root of that number with your calculator. Multiply 2 times the square root of that number with your calculator. They should be the same. Okay, so we're going to turn the page. We're going to leave this blank for now. Well, we're going to skip this for now. What I want to remind you of, we talked about this the other day, is now we're seeing powers in here of variables. And this is going to be a little, just super simple, but it's going to take a little shift in thinking. So even powers are perfect squares. Well, what do you think I'm going to write next? If even powers are perfect squares, odd powers are not. Let's prove it. Let's see. If I said, let's take 2 to the 2nd power, doesn't that equal 4? And clearly 4 is a perfect square, right? What's 2 to the 3rd power? And please don't say 6. 2 times 2 is 4 times 2 more is 8. 8's not a perfect square. What's 2 to the 4th power? Let me show you how to use the calculator to get this. 2, and this key right here just says, right here, this little caret, tells me, what power do you want to raise me to? 2 to the 4th is equal to 16. Well, guess what? 16 is a perfect square. What is 2 to the 5th power? 32. 2 to the 5th is 32, which is not a perfect square. Take a guess what 2 to the 6th is. Are you seeing a pattern here? It's 64, which is a perfect square. So even powers are perfect squares, odd powers are not. That kind of proves it. So how do we use this? Well, this is not a number. This is any positive real number. We don't know what, though. So since this is an odd power, it's not a perfect square. So we can't take the square root of this. But we can do something about it. Can you rewrite this as x times x times x? X to the third is really the same as that. Well, what if I rewrote that as x to the second, those two, times another x? Let's see if you can figure out how that's going to help. If I look back at maybe example, this guy right here, see how this is a perfect square and this is not? I take the square root of the perfect square and I leave what's not under the radical. This is a perfect square. The square root of x squared is, guess what? X. X to the first, by the way, is not a perfect square, so I leave it. So the answer to this is x radical x. Let me show you one more. What if I said the square root of x to the ninth? Now please don't get confused by this. This is not a perfect square. It's not a perfect square. These are powers, guys. This is an exponent, not a base. The base has to be a perfect square to take the square root of. So since this is an odd exponent, here's what you can think of this. See how I really just changed this from x to the third into x squared times x? Isn't this just one power lower than that, with one more here to make it x to the third? Well, that's what you do. Just change this from x to the ninth to x to the eighth times one more x, which is the same as x to the ninth. Now what? Now you're going, wait, this isn't a perfect square. Yes, it is, just like 2 to the 6 is the perfect square. The square root of x to the eighth is what you do with the powers. You just cut it in half. So the answer to this would be x to the fourth radical x. We can even do one more. The square root of x to the 101st. It's an odd power. Well, 101, this means that there's x multiplied by itself 101 times. X, 101 of them. Well, couldn't I just take 100 of them and multiply it by one more to get me back to 101 if I wanted? Well, the reason this helps is because this is a perfect square. Now be careful, guys. The square root of x to the 100th isn't x to the 10th. It's half of the power. 2 to the 4th is 16. The square root of 16 is 4, which is 2 to the 2nd. Let me do that again. 2 to the 4th equals 16. The square root of 16 is 4, which is 2 to the 2nd. This power is half of this power. So it's x to the 50th radical x is the answer. Last three examples. Here we go. 16 is a perfect square. A to the 5th is not. 16 is a perfect square. A to the 5th is not a perfect square. So what you're going to do is do what we just did here. Instead of a times a times a times a 5 times, how about if I just do a to the 4th times the 5th one here, which is the same as a to the 5th. So now, guess what? Perfect square, take the square root. Remember, this is a number that you're taking the square root of. The square root of 16 is 4. A to the 4th is a perfect square. All you do when it's a power is cut it in half. A squared. So 16's square root is 4. A to the 4th square root is a squared. And then this little sucker stays put. 4a squared radical a. Number 17, 50 is not a perfect square, but x to the 6th is, because even powers are perfect squares. They are perfect squares. But 50 isn't. Can you think of any factors of 50? Like if I said, give me 50 cents, wouldn't you give me 25 cents twice? And times x to the 6th? Now this guy right here and this guy right here are both perfect squares. He has a square root of 5. He has a square root of x to the, cut it in half, third. And he's not a perfect square, so he stays put. 5x cubed, radical 2. Last two, with 5 minutes to spare. Not a perfect square is a perfect square. Not a perfect square, do something about it. 7 x's in a row, I can really say that there's 6 and 1 more being multiplied. That's the same thing as x to the 7th. If I expanded this out, it would be x, 6 times plus 1 more, it would be x to the 7th. And y to the 10th is a perfect square. He's good. Out he goes and becomes x to the half of the power is 3. Out he goes, half of the power is 5. X to the third, y to the 5th, radical. Who's left? That guy. So another way to think of this is anytime you have an odd power, you're going to have a variable left here with under the radical. Last one, 120, x to the 2nd, y to the 8th. By the way, that guy and that guy are already perfect squares. So, 120. 12 and 10 doesn't help. What if I said 6 and 20? Still didn't help. What if I said, I don't know, what else is it divisible by? How about 3 and, oh, I got it, 30 and 4. No good, who cares, but this is a perfect square. So let's split it up. 4 times 30. X squared, extend the radical all the way, y to the 8th. Perfect square, perfect square, perfect square, not a perfect square. Out you go, I take your square root, I make you a 2. Out you go, I take the square root of x squared, which is just x. Out you go, I take the square root of y to the 8th, which is y to the 4th. You stay put. 2x, y to the 4th, radical 30. When I say stay put, though, I want you to check. What are the factors of 30, just to make sure we're done? Well, 1 and 30, who cares? 2 and 15, are either one of those perfect squares? Nope. 3 and 10? Nope. 5 and 6? Nope. We're done. So are you. Work on the homework, please. There's packets up by the calculators. Please collect all the equipment before we leave. Calculator's back, nice neat room, pushing your chairs. Hopefully you behaved. I don't want to mention any names, but you know, my favorites. They start with a D and a W and another D. You guys can all guess, and please don't. Have a nice day.